Hello students. In previous classes we have started our first chapter number system. In this one today we are going for the 1.3 exercise. In this one first part you have done yesterday. Today we are on the second one part. Second is you know that 1 by 7 is equal to 0.142857 whole bar. Can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing long division? If yes, how? I know many of you are thinking about ki 2 by 7, 3 by 7 as it is we can do as we have done previous part. But especially they have mentioned without actual long division. Then how we can do this one and what the need to give this one, why they given this. So here is one clue. See, we can go for that one. 1 by 7 already given, that is 0.142857 whole bar is there and it's a 2 by 7. What is common in both? That is denominator. 7 in both denominator is common. If we can break down in the form of this, then how we can write it? Then we can write 1 by 7 multiply 2. Is it okay? 2 by 7 that equal to 1 by 7 multiply 2. If we are going again multiply, then again we get same. So it means okay. And 1 by 7 we are having the value of, so we can put 0.142857 bar is there, multiply by 2. Then we can multiply by 2. From last we can start 14, 1, 11, 1, 17, 1, 5, 8, 2, 0 and bar is there. Okay. Now we have done without long division. Same 3 by 7. 3 by 7 we can write 1 by 7 multiply 3. So 1 by 7 we already have 0.142857 bar is there, multiply with 3. Same 4 by 7 we can write 1 by 7 multiply 4 and 1 by 7 already we have 0.142857 multiply with 4. Same as it is 5 we can write 1 by 7 multiply 5 and 6 we can multiply, write 1 by 7 multiply 6 and same form we can put and after that we can get the answer. Now see in the third one sum, express the following in the p by q form and where p and q are the integer and q not equal to 0. So we have to represent it p by q form. So first one 0.6 bar, second is 0.47 bar and third is 0.001. So I am going for the second one part, that is 0.47 bar. So let x is equal to 0.47 bar is there. So how many digit it have bar? Only one. So we can multiply with 10. So it's become 10x is equal to, now in this one as it is I guided to you. So 0.4777, so on multiply with 10. Now it's have 1 0, so point is shifted here, it become 4.77, so on. Now I can write 4.7 bar is there. First is 1 and it's a second one number. Now subtract 1 from 2. It means 10x minus x is equal to 4.7 bar minus 0.47 bar. Here 10x minus x means 1x. So 10x minus 1x, that is 9x, and here you can write now 4.7 bar. 7 bar mean to say you can write 4.77 bar and it's a 0.47 bar. So 7 bar 0 and it's a 3 and it's a 4. So it means it's a 4.30. So x is equal to 4.30 over 9. After that we can remove the decimal also. 430 over 9 into 100. 1 0 can cancel. So it's a 43 over 90. And both having no any common factor. So it's a p by q form, and here we can leave the sum. Now see in the fourth one part sum express 0.999 so on in the form of p by q. Are you surprised by your answer? With your teacher and classmate discuss why the answer makes sense. So firstly check express 0.999 so on. So indirectly you can write 0.9 bar. And after that same procedure that we adopted in the third, same here, and after that you can get the answer and you can discuss which type of answer you get. Okay. Now the fifth one, what can the maximum number of digits be in the repeating block of the digit in the decimal expansion of 1 by 17? Perform the division to check your answer. It means to say we have to convert in decimal form, and 1 by 17 that is a fraction form with non-terminating. Why? Because 17 is a prime number. So it's a non-terminating and we have to go for the long division. And you have to perform long division till your answer is not going to be repeat. Quotient is not going to repeat till you have to perform long division. Okay. Now see the next one. Look at sub-examples of rational number in the form p by q, where p and q are integer with no common factor other than 1 and having terminating decimal representation. Can you guess what property q must be satisfied? Firstly, rational number and p by q form, and p and q integers with no common factor. Mean to say p by q are the integer and both have no any common number. So it means simplest form it have. And after that are terminating decimal numbers. Terminating decimal numbers mean whenever you have to start division, it going to be finish. So if it's going to be finish, directly if I talk about terminating, then directly we can say if it's a terminating, then it form of 10, 100,000 form. It mean, or it can be 10, 100,000 form. So if it can be or maybe it have 10, 100,000 form, then if we are going for the prime factorization of that it have the factor of 2 and 5. So it mean q should be 2 into 5 form. So q should be 2 into 5 form, then it satisfy to all the property that terminating decimal expansion. Okay. Next, write 3 numbers whose decimal expansions are non-terminating, non-recurring. So any 3 number you can write as it is. I have guided to you. Non-repeating, non-recurring mean to say coefficients are quotient is not going to be same. Mean to say if you can write from your side, you can write 0.1 0 11 0 111 0 4 times 1, so on. It's become irrational number. Any number you can take 2 3 2 3 2 3, so on. So it's also irrational number. Any they are not giving any boundary. So any number 4 5 4 5 4 5 4, so on. Any number we can take that is irrational. Okay? Now the next one, find 3 different irrational number between the rational number 5 by 7 and 9 by 11. For this one, firstly 5 by 7 you have to do the long division of this one sum, and after that 9 by 11 also long division, and after that as it is I have guided to you in the example also. So between numbers you can any numbers you can write. Okay. Next, ninth, Classify the following numbers as rational or irrational. So rational or irrational number we have to classify. A rational number, that means that is a terminating or non-terminating repeating. But if it's irrational, then it is non-terminating, non-repeating. So now let's check. Under 23. 23 is a prime. It means under root is there and it's not going to be finished. So it's a irrational. Under 2 to 5 matlab 225 and it's a square of 15. So equal to 15. So under root is finished. So it's a rational. And next, that is 0.3796 and after that number is finished. So it means it's a terminating, and if it's a terminating, so it's a rational. Next, 7.478478. It means 7878 is repeated. So it's a non-terminating repeated. So it's also rational. And next one, 1.10101000 1 4 times 0 1 so on. It means quotient is going to be changed every time. So it's non-terminating, non-repeating. So it's irrational. So all our exercise is completed.